In this video, we are going to see a very applicable and important series summation 1 divided by n raised to p, and we prove here that this series is converges for p greater than 1 and diverges for p less than equal to 1. The proof of this series is a very beautiful, and with me you will also enjoy the proof of this series. The statement of this theorem here, we write this important series in terms of the theorem that the positive term series summation 1 divided by n raised to p is convergent if and only if p is greater than 1. Firstly, we show that for p greater than 1 it is a convergent, and in the second part we will prove that when p is less than equal to 1 the series is a divergent series. So in the proof, first consider that this p is greater than 1. Whenever p is greater than 1, we can see that 1 divided by 1 raised to p equal to 1. Now 1 divided by 2 raised to p plus 1 divided by 3 raised to p. Friend, we know that 3 is greater than 2, so this implies that 3 raised to p is greater than 2 raised to p, and therefore 1 divided by 3 raised to p is less than 1 divided by 2 raised to p. So here 1 divided by 2 raised to p keeping as it is, and instead of 1 divided by 3 raised to p I am going to write here 2 raised to p. So this term will be less, and we get that 1 divided by 2 raised to p plus 1 divided by 2 raised to p, that will be 2 divided by 2 raised to p, and 2 divided by 2 raised to p is the same as 4 minus 2 divided by 2 raised to p, and that is 2 square minus 2 divided by 2 raised to p. Okay, so this is we get. Now again 1 divided by 4 raised to p plus 1 divided by 5 raised to p plus 1 divided by 6 raised to p plus 1 divided by 7 raised to p, and this will be less than everywhere. Here we can see that similarly here 5 is greater than 4, so 5 raised to p is greater than 4 raised to p, and whence 1 divided by 5 raised to p is less than 1 divided by 4 raised to p. Everywhere we replace 1 divided by 4 raised to p, 4 raised to p plus 1 divided by 4 raised to p plus 1 divided by 4 raised to p. This will be 4 divided by 4 raised to p, and this is equal to 4 means here 8 minus 4 divided by 4 raised to p equal to 8 minus 4, that is 2 cube minus 2 square divided by 2 square whole raised to p. Okay, so like this. Now one more step here, 1 divided by 8 raised to p plus 1 divided by 9 raised to p plus here 1 divided by 15 raised to p. This will be less than 1 divided by 8 raised to p plus 1 divided by 8 raised to p plus 1 divided by 8 raised to p, and it will be 8 divided by 8 raised to p, that is 16 minus 8 divided by 8 raised to p, and this will be that is 2 raised to 4 minus 2 raised to 3 divided by 8 means 2 cube whole raised to p. Okay, so if we continue like this, and here if we write the general terms, 1 divided by 2 raised to n plus p plus 1 divided by 2 raised to n plus 1 whole raised to p plus 1 divided by 2 raised to n plus 1 minus 1 whole raised to p, and obviously this is less than. Okay, look at this. Whenever I have here 8 raised to p, that means I have 2 cube term here, 4, that means 2 square term, and here I have 2 raised to n term. So obviously this will be 2 raised to n, and here next 2 raised to n plus 1 minus divided by, and here I will get 2 raised to n whole raised to p. Okay, so I hope you will get here. Here you can see that whenever I have this 2 here, whenever I have this 2 here, I will get this 2 raised to 1. Whenever I have 2 square here, here I get 2 square. Here I have 2 raised to 3, then we get here 2 raised to 3. So I have taken here 2 raised to n, so here I will get 2 raised to n whole raised to p. And here we can see that if we take 2 raised to n common, 2 minus 1 divided by, here we can take also 2 raised to n into, we can write 2 raised to n whole raised to p minus 1. Hence 2 raised to n get cancelled, and we get 1 divided by 2 raised to p minus 1 whole raised to n, like this. Okay. So here we write this is also as here, this is equal to what here 2 raised to 3 means it will be similarly 2 raised to 3, 2 raised to 3 will be cancelled, and here we get 1 divided by 2 raised to p minus 1 whole cube, and here 1 divided by 2 raised to p minus 1 whole square, like this. Okay, here we can see that 4 get cancelled, and we get 1 divided by 4 raised to p minus 1, that means 2 square. Okay, so you can see that this will be. Now if we add all these terms, terms from the left and terms from the right, then what we get here, 1 divided by 1 raised to p plus 1 divided by 2 raised to p plus 1 divided by 3 raised to p plus here 1 divided by 2 raised to n plus 1 minus 1 whole raised to p. This is less than. Okay, I am going to erase this, some part of this, so that we get the clear idea about these terms. Right, you can see that what we get, this is the left side and this one is the right side, which I have put as it is. I am going to once again write here 1 divided by 1 raised to p plus 1 divided by 2 raised to p plus 1 divided by 3 raised to p plus 2 raised to n plus 1 minus 1 whole raised to p is less than 1 plus 1 divided by 2 raised to p plus 1 divided by 2 raised to p minus 1, 2 raised to p minus 2 raised to p minus 1, here 2 raised to p minus 1, 2 raised to p minus 1, here we get 2 raised to p minus 1, 2 raised to p minus 1, here is also 2 raised to p minus 1, and here we get 2 raised to p minus 1 whole square plus 1 divided by 2 raised to p minus 1 whole raised to n. And look at this, this is what, this is s raised to 2 raised to n plus 1 minus 1, this term, and this will be less than 1 plus 1 divided by 2 raised to p minus 1 plus 1 divided by 2 raised to p minus 1 whole square plus 1 divided by 2 raised to p minus 1 whole raised to n, and this is the geometric series, and this geometric series converges to 1 minus 1 divided by 2 raised to p minus 1 whole raised to n plus 1 divided by 1 minus 1 divided by 2 raised to p minus 1. Now here you can see that what we get here, s to raised to n plus 1 minus 1 is less than 1 minus 1 divided by 2 raised to p minus 1 whole raised to n plus 1 divided by 1 minus 1 divided by 2 raised to p minus 1. Now this is equal to, let us take the reciprocal in the denominator. So this denominator will goes into numerator and we get here 2 raised to p minus 1 and the bracket term as it is 1 minus 1 divided by 2 raised to p minus 1 whole raised to n plus 1, and in the numerator we get 2 raised to p minus 1 and this minus 1. Okay, now this is the bracket terms, this is the fraction. That means this is a number, suppose this number is 5 and this is a fraction, suppose this is 0.1, so its multiplication will be 0.5. That means it is less than 5. So obviously we take the greater term 2 raised to p minus 1 divided by 2 raised to p minus 1 and this minus 1. That is s 2 raised to n plus 1 minus 1 is less than 2 raised to p minus 1 divided by 2 raised to p minus 1 minus 1. Again friend, we know that this 2 raised to n plus 1 minus 1 is greater than this 2 raised to n and this is greater than n. So obviously this Sn is greater than s2 raised to n and this is less than this s raised 2 raised to n plus 1 minus 1, but which is less than 2 raised to p minus 1 divided by 2 raised to p minus 1 minus 1. That means this term Sn, sequence Sn is a bounded. This gives us a bounded sequence, but sequence is a monotonic increasing since the series is a positive term series. As series is a positive term series, its sequence is a monotonic increasing sequence, and monotonic increasing sequence when bounded above it is a convergent. And here Sn is a monotonic increasing sequence which is bounded above, so Sn is convergent. And series is sequence is convergent, so series is also convergent. Now we show that whenever p is less than or equal to 1, the series will be divergent series. In the second part of the proof we show that in the first part of this proof we have proved that the series is a convergent. Now in the second part we consider that this p is less than equal to 1. P is less than equal to 1, that means if we have p equal to minus 1, then 2 raised to minus 1 and 2, what is the difference? 2 raised to minus 1 is 1 by 2 and 2 raised to minus 1, 1 by 2 is less than 2. Okay, so 2 raised to minus 1 is less than 2 whenever, so when we consider 2 raised to p and 2, 2 raised to p is less than 2. And if we take the reciprocal of this, so obviously 2 raised to p is greater than 1 by 2. So we are going to use this idea to prove this. Now consider the term 1 plus 1 divided by 2 raised to p, and we know that 1 plus 1 by 2, here we have seen that 1 divided by 2 raised to p is greater than 1 by 2, so obviously it is greater than 1 by 2 but this is greater than 1 by 2. Now 1 divided by 3 raised to p plus 1 divided by 4 raised to p, this is greater than 1 by 3 plus 1 by 4. As 3 is less than 4, 1 by 3 is greater than 1 by 4. So we take the smallest term 1 by 4 plus 1 by 4, and 1 by 4 plus 1 by 4, that will be 2 by 4, and 2 by 4, this is equal to 1 by 2. Similarly here 1 divided by 5 raised to p plus 1 divided by 6 raised to p plus 1 divided by 7 raised to p plus 1 divided by 8 raised to p is greater than 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. This is greater than 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. This is equal to 4 by 8, and this is nothing but 1 by 2. So it is greater than 1 by 2. Now continuing in this manner, we write here 1 divided by 2 raised to m minus 1 minus plus 1 whole raised to p plus 1 divided by 2 raised to m minus 1 plus 2 whole raised to p plus 1 divided by 2 raised to, here we get m and whole raised to p. This is greater than 1 divided by 2 raised to m minus 1 plus 1 divided by 2 raised to m minus 1 plus 2 plus 1 divided by 2 raised to m, and obviously we get that this is greater than 2 raised to m minus 2 raised to m minus 1 divided by 2 raised to m, and which is equal to 1 by 2. So here this is the total sum, adding all this term, adding what we get here, this will be s to raised to m terms. S to raised to m term is greater than 1 by 2, 1 by 2, 1 by 2 in the right side. Here we are adding all this term, 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. How many times? This m times m terms plus 1 by 2 plus 1 by 2 plus 1 by 2. So this will be m by 2, and here this shows that if we take g, whatever may be a large number, g is a large, we have the term m by 2, we have the number m by 2 which is greater than g, and m by 2 is greater than g means s to raised to m is greater than 2. So this sequence Sn is not bounded above, is not bounded. If it is not bounded but it is a monotonic increasing, so it is a not convergent. As sequence is not convergent, the series is also not convergent. So friend, I hope you have get the idea of very important series, that is summation of 1 divided by n raised to